third lecture, which is going to be section 2.4, addition of force system of coplanar forces. So today's objective, we're going to be able to resolve a force in a Cartesian coordinate components and know how to the sum force components to get resultant from Cartesian components, and know how to write the coplanar force as Cartesian vector, and know how to get the resultant force magnitude and then direction. So force is resolved into two components along the x and y axis. The components are called rectangular components. So for any analytical work, the components are represented in terms of scalar vector notation or in Cartesian vector notation. So we're going to be focusing on how we show that in scalar and how we show that in vector notation for the forces. So let's look into the scalar vector notation. So let's assume that we have a force F acting on an xy plane which has the components of fx and fy acting in x and y axis respectively. So this force F is acting at an angle inclined at theta from our horizontal. So how do we represent our fx? So we can represent fx in terms of f as f is equals to cos theta. So how do we get that? So let's take this triangle over here. So we have theta. So if we use cos theta for that triangle, so the cos theta will be our adjacent side, that is our fx divided by f. So if we want to find fx, we can take fx as subject, which will give us that fx is equals to f cos theta. So this is our horizontal component. Similar thing we can do for vertical component by using sine theta, which will give us the fy over f. So we can make fy as the subject and we can get that fy is equals to f sine theta. So this is how we give it in scalar vector notation, the forces. So now let's look into how we represent it in Cartesian vector notation. So another method for showing the coplanar forces in terms of scalar vector notation is, once you are given the angle, you can use this method. But if you are not given the angle, but you are given the slope of your force. So for example, this F, we know what's the slope, that is A in horizontal, B in vertical, and hypotenuse in C. So if we are given that, how do we get that one? So for that, we can consider the small triangle with the slope, that is our with the sides A, B, C, and then we can get the bigger triangle, that is with our fx, fy, and our f. So we can use concurrency on the both triangles. So we can equate the sides from the big triangle and the small triangle. So we have the big triangle fx. So the corresponding side to fx is our A. You can see the horizontal. So we have A. So we are dividing fx by f. So that's the hypotenuse. So the corresponding hypotenuse is C. So similarly, from there we can get fx, that f times A by C. So this shows that any horizontal force, if you want to find out any horizontal force of your f, of your force F, if you have a slope of the force, you can get it by dividing the horizontal side divided by your hypotenuse times your force. That will give you a horizontal force. So here we are using horizontal side for horizontal force, and then for in case of vertical, what we are going to do is we are going to use vertical side. So our vertical side is B in the small triangle, which is the slope of your force F. So from there we can get Fy is equals to F by B by C. So now let's look how we're going to give that in Cartesian vector notation. This might be the one we will be mostly using. So if the question is asked to give the forces, if the forces are given in scalar notation, so you can give scalar vector notation. If they are specifically for vector, then you can do that. So what we do in Cartesian vector notation, we resolve the vectors into components using the x and y axis coordinate system. Each component of the vector will be shown by a magnitude and a direction. So like previous one, so we have the x and we have an x and y axis. instead of showing x and y, so for showing the direction, we will represent the horizontal direction in x direction by using a unit vector which is I. And similarly for vertical, we'll be using a unit vector which is j. So this fx will give you the magnitude, and then I will tell you that is in horizontal direction, and j will tell you the direction of that. So this is how we represent in Cartesian vector notation. So these directions are based on the x and y axis. So as we mentioned before, we use these unit vectors I and j to designate the x and y axis respectively. Now let's see how we are going to denote in Cartesian vector. So our force F is going to be a summation of Fx in direction I plus Fy in direction j. So how are we giving our F? So we give the F that's equals to our Fx in I in horizontal direction and Fy in our vertical direction. So that's our magnitude and that's our direction. Or else, let's say this example where we don't have a horizontal or vertical, it's just a random x and a perpendicular axis y. And we know that's I and that is in negative j. So how do we apply the resultant f is going to be its component one first magnitude of that component fx bar into the direction I plus the magnitude of the force that is Fy and then the direction which is negative j. So that's how we apply, that's how we present it in the Cartesian vector notation. So the x and y axes are always perpendicular to each other. Together we can say that can be set at any inclination. We don't need to be like always perpendicular, we can have it in any direction. So now let's focus how we are going to do addition of several vectors. So we're looking to two vectors, but let's see how we do it. Going to do for several vectors. So step 1 is always to resolve each force into its components. Then step 2, if you have x component, you add all the x components together, and then you have y component, then you get all the y components together. Let's see how we do that. So we have f1, and then we have f2, and then we have f3. So what we're going to do first, because these are in different directions, right? So we are not going to going to draw parallelogram or triangle. We can do that, but imagine you have fn number of forces. There it's very hard for you to draw parallelogram or triangle draw. So how do we going to add that one? So the simple step is first we're going to resolve all the forces. So we have f1, so you result in the horizontal and vertical. Then your f2 horizontal and vertical, and we resolve the forces in horizontal and vertical direction. Then you find out the magnitude and angle of all these forces by adding up. So let's take the horizontal side, that's our x-axis. So we have f1 next forcing in the x direction and f2x in the opposite direction. So we negative f2x and then we have f3x. So they give you the forces or the resultant force or the addition of forces in the horizontal direction. Similar thing you can do for vertical one. So let's see that example again. So we're going to act it in Cartesian vector. We know in applying in Cartesian vector, we have to get the resultant of the forces in terms of all the x components and times your I plus y components times your j. So we have resultant force or the addition of all the three forces. That's what the resultant is. So it's going to be F1 plus F2 plus F3. So we can represent F1 in terms of F1I, that's this format, and then F1J. And we know F2I is negative direction, so F2X and F2Y. Then similarly we have for third. So now we get all the horizontal components and the direction and all the horizontal vertical component and then the direction. So this is how we add the forces. So we can always represent a 2D vector with a magnitude and then an angle. So that's how we're going to represent that. So we have a resultant of these x and y components. So how do we represent the magnitude? So the magnitude, we know that Fr is going to be square root of your horizontal forces. So this is just the magnitude. That is kind of like a scalar one, so it's not a vector, right? because vector form we know how do we give it the direction. So now we are not dealing with direction, so we just square this one to get the magnitude in terms of rx and ry. So how do we get theta? Simple, you can use trigonometry and you can use the sides to get the tan inverse of the force. So from this you can represent the resultant force in terms of magnitude and direction. This is how you usually give in a question. If they ask to represent, you give you the resultant force. If you're going with a scalar, you can give it the magnitude and the direction. Otherwise, we can give in I and J terms. So we'll be doing some problems in that. Let's look into this first problem. So we have three concurrent forces acting on a chain post. So the magnitude and angle of the resultant force is what they are asking to find. So let's look into the forces. F1 is not going to give us any problem because it's just a vertical one, so we are fine with that. But F2 is acting 45 with the horizontal, so we need two components for F2, and F3 2 is acting in a slope, so we are going to get two components in horizontal and vertical. So what's our plan? We're going to resolve all the forces, and then we are going to add the respective components, the horizontal and the vertical ones. Then we are going to find the magnitude and the angle from the resultant components. So let's look into this one. So our F1 we can represent in terms of horizontal, there is 0, so that is 0I, and the vertical is 300J. So how about F2? Think for a moment. Let's see whether what you guess is correct. So we have 450. That's not in I direction. I want in I direction. So we know that for I direction we use horizontal component, we use cos 45 and plus, that's your I, and your vertical components is 415, yes, sine 45 and J. So that's what we have here, and we get the solve it and get the magnitudes. Similar thing we can do for F3. Let's see, you remember how to do that. Don't go and look back the notes. Can anybody guess what's the value? Okay, let's see what you think, what you thought, and what I'm going to write is same. Since we are going to get the horizontal one, I said we use the horizontal side, that's 3 divided by our hypotenuse, that's 5I. Did you guess that correct? And then the vertical one, how do we get that? Yes, I hope you guess it correct. So that's the vertical one divided by 5 into J. Perfect. So we have that one there. So we have all the horizontal and vertical components of a force. Now our task is easy. It's just going to be addition. So we are going to sum up all the i's and j's. So there we go with the I and j, and finally we have a resultant. So how do we get the magnitude of the resultant? Yes, I hope you get it correct. So that's going to be the addition of the square of both components will give you the magnitude, right? How about you get the direction? Yes, so direction is tan of that. Perfect. So I hope you understood how to find it. So if you have more forces, resolve them all into horizontal and vertical directions. Give them in scalar or vector notation. You can give it in items, or then you get the magnitude, and then you get the direction. Then you have all. Okay, you can solve this problem on your own. I can give you like 10 minutes and we can look into the notes. But so let's look into the plan of that. First, we are going to construct parallel lines to the U and V axis. Then we form a parallelogram. Then you're going to resolve the forces in the U and V components. Then we find the magnitude. So look into the examples and solve problems. And if you have any questions, please let me know. இல்ல அவர் ஒன்றும் தரையில மாமி. இல்ல அவர் எடுத்ததே சொல்லல அவர் அவர் ஃப்ரெண்ட்ஸுக்கு கொடுக்குற